So this is the device which titled Data Acquisition for Smart Greenhouse. In this device we have three modules. Firstly, on the left side we have LDR, light dependent resistor. You can see here there's a light dependent resistor here. So basically, if we let light go through the surface, then the resistance will increase, and if we didn't let any light to hit the surface, then the resistance value will go down. And the pin we use are the analog output, which we connect it to the Arduino, this red cable, to the analog pin A0. On the next module, in the middle here, we have HDT11, which is a humidity and temperature sensor. It will measure the humidity and the temperature around it. And the pin we use are digital output pin, so we connect the pin to the digital pin number 9 here. And then if you're wondering what is this resistor in the middle, it's a pull-up resistor. So basically, on the datasheet, it is mandatory for the user to have a pull-up resistor connected from the output pin to the positive side. And lastly, we have this module, which is a micro SD module. It is used for data logging. On top here we have a micro SD here, right here. The pin we use are, you can see that ground, VCC, master in, slave out, master out, slave in, MISO, MOSI, and then SCK and CS chip select, which we connect it accordingly to the datasheet of the Arduino and the datasheet of the micro SD. And then that's all from the configuration of the device. We can see here, after we upload the program to the Arduino, we have the value of the LDR, humidity, and the temperature. We can see if I didn't let any light to come to the surface, the LDR value will decrease. So because it is indoor and I put my AC on, the temperature is pretty cold for Jakarta because it is indoor. It's 24.5 Celsius, and it is said that the humidity is around 56%. So yeah, that's my system for my project.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ismail Faruqi, and I'm from Electrical Engineering 2024. So in my final project, I make a data acquisition for smart greenhouse.
So then we can
for the complexity of the problem,
and we can compare it with,
we know that managing greenhouse environment, especially manually, can be challenging. We need temperature, humidity, and light intensity, which are important for crop growth. And monitoring them accurately and consistently will require a lot of time and effort. error in the manual data collection will result in a not so optimal growing condition. Thus will reduce the crop yields. And additionally, most modern farmer, traditional farmer, lack affordable tools for automated monitoring and data analysis, which complicate the problem. And then the solution that we are trying to make is I developed an automated greenhouse monitoring system which use sensors to measure the climate parameters and then log the data into a micro SD card. The system provides a real-time and accurate data which will allow the farmer to analyze the data which they could make analyze it and then make decision from the analysis, and then they will optimize the growing condition. By automating this process, the system minimize human error and will increase the efficiency for the farmer. Our system is using a measurement algorithm which operates in a loop, which we acquire the sensor data and then validating it and then storing it in the micro SD. The component that we using, we have 4 main components. The first one is Arduino Uno, and then the HT11 sensor which measure the temperature and humidity, and then we have LDR module. LDR stand for light dependent resistor, which this sensor is for measuring light intensity. And lastly, we have micro SD module, which for putting our micro SD for the data logging. So the operation we have set up, which we connect all the components and the device via USB or other power source. And then for the data acquisition, the Arduino reads sensor value every 20 minutes, and then the sensor value are validated and then we convert it to units, and then finally the data we record it, we save it to the micro SD card with timestamp so that we can track the time. And lastly, if we for some 2 weeks or 1 month, we record the humidity, the temperature, and then the light intensity, we can pull out the micro SD and analyze the data. So basically that's it from my project. So I hope this system of automating the climate monitoring will improve the efficiency and then maybe will help farmers to have more efficient workflow. That's all from me. Thank you.